What happens when stuff dissolves, and what happens to the atoms and molecules that make it up. If you had atomic vision and you could see the atoms that make up salt and what it looks like as these grains broke apart and became invisible, that's what I'm going to talk about here. Compounds are composed of atoms held together by chemical bonds, and chemical bonds are formed because we had attractions between the charged particles that compose atoms. Charged particles exert electrostatic forces on one another, like charge repel and opposite charge attract. The forces are responsible for chemical bonding. We can classify most chemical bonds into two types, ionic bonds and covalent bonds. So now I'm going to talk about table salt. Salt is an ionic compound made of metals and non-metals. It is made of sodium ions, Na+, which are metals, and chloride ions, Cl-, which are non-metals. About like what you see with your naked eyes, salt is a white powder made of little grains, and when poured into the water for cooking or another activity and we stir around, you see the grains getting smaller and maybe break apart until eventually totally disappear into the water. About the dissolution of salt in relation of atomic vision. If we take a grain of salt and we dip it into water and start stirring around, and with our atomic vision we are going to see that the atoms that make up the salt are going to become apart from each other. They are going to break apart, and all of them are going to start floating around in the water individually. This is what happens when salt dissolves, so they break apart into individual
We're going to see how we determine the formula of ionic compounds. Ionic compounds occur in Earth naturally as minerals. Table salt is one of the most common examples. And ionic compounds are very stable thanks to the strong attractions between cations and ions. And since ionic compounds present a neutral charge and many elements for only one type of ion, we can predict the formula of the ionic compound, from its elements and the charges. So we're going to see here, we have the example of table salt, which is sodium and chlorine. And first of all, we get the ionic charges from the periodic table, and we see that sodium, or Na, has a +1 charge. That meaning that it has only one valence electron in its outer shell. So in order to gain stability, it's going to lose, it's going to donate one electron, and that's hence the charge +1. Now in the case of chlorine, or Cl, that has a -1. That means that it has 7 electrons in the outer shell, 7 valence electrons, and it's going to need one more electron. It's going to gain one electron to complete the octet and gain stability. So when we write it down, first we put the cation, which is going to be the positive charge, sodium. So in this case, the simplest method for me, I believe, is the crisscross method, where we just cross the charges to the subscripts of the other element. So you have one for Cl and one for Na. And that's going to give us a ratio of 1 to 1. And that's how we determine that the formula will be NaCl.
Okay, now I'm going to explain how to name ionic compounds. Some ionic compounds, such as table salt and baking soda, have common names that we use in our daily life in order to avoid the complicated names that chemists use in the chemistry field. How I said, chemists have developed systematic names for different types of compounds, every kind of compound, in order to easily identify the compound we are talking about. Even if we are not too familiar with a compound, we can determine its systematic name from its chemical formula. Conversely, we can deduce the molecular formula from its systematic name. So, in order to name an ionic compound is to identify the type of substance we are talking about. It means that we have to know what kind of substance we have. Remembering that any ionic compound is usually composed of a metal and a non-metal compound, every time we see a metal and one or more non-metals together in a chemical formula, we can conclude that we are talking about an ionic compound. So the second step in naming the ionic compound is to identify the metal in the compound. We already know that we are talking about an ionic compound because we are working with table salt. So now what we have to do is identify the metal in the compound. Okay. So basically, the difference in between both groups is that the first group contains metals whose charge is invariant from one compound to another. The metals in this group are also called alkali or earth alkali metals. And the second group of ionic compound contains a metal that can differ in different whose charge can differ in different compounds. In this case, the metals we used to have are the transition metals. So now, knowing that the compound we are talking about is an ionic compound and the metal we have in this ionic compound is sodium, which is an alkali metal, we are going to name in a chemical way our table salt. Looking at the formula of the salt that we already deduced, we can see that it's composed of only two different elements. In this case, we have sodium and chlorine. This kind of compounds in which there are only two elements are called binary. The format for naming this kind of compounds is using the name of the cation as at the beginning of the name of the compound, followed by the name of the anion with the ending IDE. So the full name of this ionic compound is going to be sodium chloride.